Good day, viewers, and welcome. Let's solve for x in this equation. The first thing we are going to do to comes to our mind is the value of x here can take this. If x equals to 1, so it satisfies this equation, and x equals to 0 satisfy it. But if x equals to negative 1, it's not satisfied. And all these three, they follows the rules of trichotomy, or you can call it the piecewise function. So, and during this course, I'm going to apply the Lambert. So at some stage, so I'm going to write the formula here. If I have omega of x exponential x equals to x, and this thing is constant, all right, so which means we are taking only x as in the coefficient of exponential x. Anything we see there, so we take it as the result of this. And let's solve this. The first thing we're going to do is by separating this. So since it takes two different powers, so we separate it with their common base, and we have this. And we take this one here as an x square, we take it to this side. So here we have x raised to power x dot x raised to power 2 minus x raised to power 2 equals to 0. And here we have x raised to power 2 that is common. If we take out x raised to power 2, here we have x to the power of x minus 1 equals to 0. And we are going to have two things here. So we let x raised to power 0 equals to 0. And we also let s to the power of x minus 1 equals to 0. So for the first one here, we have x, we take the root of it, and we have the root of this. So if root cancel root square root, we are going to have x equals to 0, so which is the first root according to that law, as s equals to 0. And let's deal with this. So here is where I'm going to apply the Lambert W function for this, though we can guess, but let's solve it for real. And if we introduce ln to this, so just to take the power of x down, so we have here as ln1 and equals to ln of 0. So ln is also known as natural logarithm, so we take s down, then we have this equals to ln of 1. And I'm going to apply something here. So suppose we have x equals to we have exponential of ln of x. So these two is equivalent to x because exponential and ln, they are inverse. So by changing this x to exponential of ln x, then dot we have ln x equals to ln 1. And so if we want to follow the Lambert, we take this ln x, we take it to the back, and we write exponential ln x equals to ln 1. And so we have the coefficient and this power to be the same. We introduce the Lambert, so which is the w. And since this one has been obeyed, the Lambert rules, so we are going, according to this, we are going to take only ln x equals to omega bracket ln 1. And I'm looking for x, so I'm going to introduce exponential to both sides. So by introducing exponential, we have these two cancel since they are inverse, and we have x equals to exponential omega ln 1. And we can stop here, but since from what we have defined, so we let this equals to a number which is s equals to 1. So by plug this in the word frame, so we are going to get the answer as equals to 1 as this. Thanks for watching. Don't forget the steps I use. Subscribe to my YouTube channel and turn on the notification bell. And don't forget to like this video, share it. I will see you in the next class. If you have any question to ask, you can drop it in the comment box.